Hi, I'm Fred Dillon, and I'm going to be talking about using rates and proportions. A ratio is a comparison of two numbers. It can be written in several ways: 3 dogs to 2 cats, 3 to 2 in vertical, or horizontally, 3 to 2, 3 dogs per 2 cats. Labels are not necessary but can be helpful. The ratio is generally read as 3 to 2. It is not correct to read this as a fraction, 3/2. One type of ratio is referred to as a rate of change. For an example, an exchange rate is a ratio. This may be expressed as $4.63 in American money is equal to 2.50 pounds in British money. Another ratio is 35 miles per hour. This means there is a ratio of 35 miles traveled per 1 hour. Air pressure is frequently labeled as 34 psi. This is a ratio expressing 34 pounds per square inch. A unit rate is one in which the second term is 1. Both miles per hour and pounds per square inch are examples of unit rates. A ratio may be written to compare any two quantities, and as with a fraction, has equivalent forms. 34 is to 48 is the same as 17 is to 24, which is the same as 51 is to 72. It is sometimes beneficial to use another form. For example, 12 for 2 books may be easier to look at as a unit rate, $6 per book. Odds are a way of reporting probabilities. Odds are a ratio of number of successes in an event versus number of failures. A person may have a 30% chance of contracting a disease. That is, 30 out of 100 times we would expect the disease to be contracted. The odds of contracting the disease are 30 to 70, or 3 to 7. There are 16 rabbits with white fur of a group of 34 rabbits. There are 2 ways to write a ratio for this. Students frequently have a difficult time with this. One type of ratio is called part to whole. That means we would look at just the rabbits with white fur and compare them to the total or whole amount. This makes a ratio 16 white rabbits to 34 total rabbits. It is also sometimes used to compare white rabbits to non-white rabbits. This is referred to as a part-to-part ratio. You must subtract 34 minus 16 to get the other part. We then have the ratio 16 white rabbits to 18 non-white rabbits. The law of sines can be looked at as a set of 3 equal ratios. The sine of angle A over the length of side A is the same as the sine of angle B to the length of side B, which is the same as the sine of angle C to the length of side C. Missing parts of a triangle may be found by solving for missing parts of the ratios, which leads us to the idea of a proportion. A proportion is 2 or more equal ratios. 3 is to 2 as 6 is to 4 is one way to write this horizontally. We can also use the vertical notation, which is also read 3 is to 2 as 6 is to 4. Once again, it is not proper to say 3/2 equals 6/4. These are not fractions. Many of the ratios mentioned earlier are used in proportions for problem-solving purposes. If the exchange rate is $4.63 in American money is equal to 2.50 pounds, how many pounds are exchanged for $100? We set up a ratio, $4.63 to 2.50 pounds, and another ratio, $100 is to X unknown pounds. The process of solving this involves multiplying both sides by the quantity 2.50x. You can see here we have 2.50x using multiplicative equality on each side. Because x over x and 2.50 over 2.50 are forms of 1, we can rewrite this as 2.50 over x and make those terms make a form of 1. This is the same as saying 4.63x equals 2.50 times 100. Because of this format and what has reduced to 1, we say we have cross-multiplied. This gives us 4.63x equals 250, which we can solve to get approximately 54 pounds is equal to 100 American dollars. Suppose a given population has 5 of every 9 people with type O positive blood. In a population of 634,000, how many people would be expected to have type O positive blood? Our original ratio is 5 to 9, and our other ratio now has the part unknown. It becomes T is to 634,000. We use the quote cross-multiplying method, and we get 9t equal 5 times 634,000. Solving this gives us a decimal that we round to have approximately 352,000 222 people. A proportion may also be called a direct variation. Y is to X is our ratio, and that is set into proportion equal to K over 1. This shows a proportional relationship between X and Y and a constant called K, the constant of proportionality. This may be rewritten as Y equal Kx, where K is the slope and where the origin is the y-intercept. We have just learned how we can use unit rates, how to set up a ratio, and how to set up and solve a proportion.